For this problem, we're asked to solve a rational inequality. In other words, a fractional inequality. Let's review the steps for solving these types of inequalities. Step 1, you're going to move everything onto the left-hand side. The other side will be 0. Step 2, if there are more than one terms on that side, there's more than one term, like terms are values that are being added and subtracted together, you're going to find a common denominator and make it into a single term and factor the top and bottom. You want a single fraction on the left-hand side. Step 3, you're going to set the top of the equation, the fraction equal to 0 and solve. And then step 4, you're going to set the bottom equal to 0 and solve. From those two steps, step 5, you're going to use all the real x values, the solutions that you find for step 3 and 4. You're going to use those to partition the number line. Step 6, in each region, you're going to find the sign of all the factors, top and bottom, and the sign of the single fraction that's on the left-hand side. Step 7, you're going to shade the regions that make step 2 true, the factored form of your inequality as a single fraction. And then step 8, you're going to decide whether or not to include or exclude the endpoints. So, step 1, move everything to the left side, make it into a single fraction. Well, it's already on the left side, and we have a single fraction, step 2. So what we want to do now is we want to set each of the top, for step 3, set the top equal to 0 and solve x equals -3. Step 4, set the bottom equal to 0 and solve. We're going to have to factor x plus 2 times x minus 2 equals 0. And we solve, we get x equals -1, union together with x equals 1. Okay, step 5 is where we draw the number line, and we're going to partition the number line using the real values that we got in the solution. So it's going to be -3, 1, and let's see, -3, 1, -1, and 1. Right. Okay, now we are going to check each of the regions for the signs on the top and the bottom of this fraction. Okay, on the top we have a negative in this region. Well, I'll get ready first by drawing the fraction bar in the parentheses for each of the factors. Okay, for the first region, we have a negative on top. On the bottom, a negative and a negative multiplied together is a negative over positive. That's a negative. Then we have a positive on top, 2 negatives on the bottom. That's going to give us a positive for that entire fraction. A positive on the top with a positive and negative on the bottom gives us a negative. And then finally, a positive over a positive times a positive gives us a positive. Okay, so for step 6, we want to make sure that we have each of the regions sign, the sign of the entire fraction for each of the regions. We've done that in the circles on the bottom. Step 7 says go back to step 2. And what did step 2 say? It said the single fraction in its factored form, x plus 3 over x plus 1 times x minus 1, is greater than or equal to 0. Now, to be greater than 0 means to be positive. So we're going to go back to our graph and shade each of the regions that give us a positive result for the entire fraction. That happens in the middle region. It happens in the far right region. So just shade those two regions that give you positive values for the entire fraction. Now, for step 8, okay, shade, shade, shade. Oh, there you go. Okay. Shade that, shade that. Okay, now for step 8, I got ahead of myself because this is where I'm supposed to decide if I'm going to include or exclude my endpoints. And I actually already did it without telling you. So let's just cover why I did it. I should have waited until step 8. The original inequality sign had an equal portion. It was greater than or equal to. That means that we will include our endpoints, and I'll write those endpoint numbers in set notation. I'll list them. There's -3, -1, and 1. So go back to the graph, and we're going to put boxy brackets on those numbers. But wait a minute. Step 8 said something very important, which I forgot to emphasize. You want to also exclude any x value that produces a 0 denominator in your single fraction that you have on the left side. So for that reason, we are not going to be allowed to keep the -3. I'm sorry, not the -3, but let's see, the -1 and the 1, because each of those make the denominator 0. So that means we're going to have to exclude those two numbers. Let's see, both of them? Well, let's see here. Yeah, it looks like we're going to have to exclude those two numbers because each of those, if you plug them into the denominator, gives you a 0 denominator. So that means that our solution, if you look back up to the graph, we have a boxy bracket on -3, but round brackets on -1 and +1. So now express that graph in the three solutions methods. Set notation, real value is x, such that -3 is less than or equal to x is less than -1, union together with x is greater than 1. I was really careful about where I put the equal portion in there. Interval notation, boxy bracket, -3 to -1, open bracket, union with open bracket 1 to infinity. And then just repeat the graph from step 5. The number line, the numbers -3, -1, and 1. Shade the applicable regions and put the proper arrows or brackets, boxy or round. And that is our solution.